हेलो एवरीबॉडी। बच्चों आज हम शुरू करते हैं। वी आर गोइंग टू स्टार्ट अ वेरी इंपॉर्टेंट टॉपिक ऑन एटॉमिक स्ट्रक्चर एंड दैट इज क्वांटम नंबर्स। How these numbers were discovered, who discovered these numbers, what was the reason behind discovering these numbers. Let's talk about them. First of all, why there was a need for these numbers. You have heard about Schrodinger. Schrodinger gave Schrodinger wave equation, and that ultimately led to the discovery of modern concept of atomic structure, which was accepted by everybody, and that was quantum mechanical model of an atom. Why this so? Because you have read in the previous lectures that several scientists gave models regarding the structure of atom. Thomson gave Thomson's model of an atom. Then it failed. I've explained in my lecture why it failed. Then Rutherford gave Rutherford's model of an atom along with his disciples, or we can say along with his students. I'm not very sure about that word disciple. It also failed. Then came Bohr's model of an atom. It also failed because of reasons explained in my lectures or given by the scientists. Then came Schrodinger wave equation, Planck's quantum theory, Heisenberg's uncertainty principle. These ultimately led to a modern concept of the structure of atom, and that because of Schrodinger wave equation, which gave ultimately to this modern concept of the atomic structure, and that was called quantum mechanical theory of atom, which ultimately led to the concept of orbitals, which disregarded or discarded the concept of orbits in which electron revolves. So ultimately, that Schrodinger wave equation was responsible for the birth of quantum numbers. For Schrodinger gave quantum numbers, and he gave only three quantum numbers. There were four quantum numbers. Principal quantum number first, second was, yes, Azimuthal quantum number, third was magnetic quantum number, and fourth was spin quantum number. Out of these four quantum numbers, three quantum numbers, principal quantum number, azimuthal quantum number, magnetic quantum number, it was the result of Schrodinger wave equation or discovered by Schrodinger, because he gave the position of energy of electrons in an orbital or in an atom. So the quantum numbers were necessity to give the complete address or complete information about an electron in an atom. So now you have understood why there was a need for quantum numbers, who exactly discovered these quantum numbers, and what are the types of quantum numbers. So let's have the detailed information about these quantum numbers. As you have came to know now that quantum numbers, they are set of four numbers. They are set of four numbers. Is it right? And discovered, or you can say given, by Schrodinger. That's right. Not all the four quantum numbers, only three quantum numbers. Which three quantum numbers were given by Schrodinger? The first was principal, quantum number. The first was principal quantum number represented by symbol small n. The second was azimuthal quantum number, azimuthal quantum number represented by symbol small l. The third was magnetic quantum number, magnetic quantum number represented by symbol small m, or you can also write ml. Is it right? So these three quantum numbers was given by Schrodinger. So these were based on Schrodinger wave equation. So basically these were based on Schrodinger equation, you can say. Schrodinger equation, Schrodinger wave equation, you can say anything. And the fourth quantum number, that is the spin quantum number, it was discovered later. Spin quantum number, fourth one, spin quantum number was represented by symbol ms, or simply you can say s. It was discovered later on. It was not discovered with these quantum numbers. It was discovered later on during the discoveries of the structure of atom, or during the discoveries, other discoveries. Okay, so let's have the detailed information about the principal quantum number first. So I'm rubbing this one. Please note it down. Pause the video and make the notes. Learn them. Principal quantum number represented by symbol, represented by symbol, as I have told you, small n, right? And what information, and n gives the information about shells. So n is equal to 1, 2, 3, 4, etc. Shells, orbits, anything you can say. So what is the significance of this one? Significance means importance of this one. What does exactly it explains? It gives information about the shells. It means it explains or gives information about the shells. It also gives information about the size of orbitals, size of orbitals, and it also gives information about the energy of orbitals. So these three very important information: energy of orbitals. These three very important information about the electron or electrons is given by principal quantum number. Please note it down. Pause the video and note it down, please. Now let's have the next quantum number, and that is your azimuthal quantum number. It is also known by other names like subsidiary quantum number or orbital angular momentum quantum number, you can say. So this is the next one is, let's have the second one, that is B, azimuthal, MUTH, this is H. Azimuthal quantum number, also known by other names, I have told you. Remember, what are those? Can you? Yes, that is, it is also called subsidiary quantum number. One other name also I told you. What is that? They are called orbital angular momentum quantum number. Orbital angular momentum quantum number. Is it right? So, next, its symbol, how it is represented. It is represented by, its symbol is short, in short we can say, its symbol, it is represented by L, small l. And there is a relation between azimuthal quantum number and the principal quantum number. If you know the principal quantum number, you can calculate the azimuthal quantum number by applying this relationship. So, what is the relationship between the two? Relationship between the two is 0 to n minus 1. That is, L is can be calculated by using this relationship 0 to n minus 1. So let's have example for that one. So let's have example. If suppose that this is azimuthal quantum number, suppose that n is, let n is 3. So what will be the possible values of L? Therefore, L will be equal to 0 to n minus 1. So this will 0 to 3 minus 1 or 0 to 2. So it can be written as 0, 1 and 2. So the possible values for any value of 3, if n is equal to 3, the possible values of L will be 0, 1 and 2. It can be any one, 0, 1 and 2. Lots of questions came from here or come from here. We will discuss later on. So, what is the significance of azimuthal quantum number? Let's have the significance. What information it gives? Significance of azimuthal quantum number. It gives information. It gives information. This quantum number gives information about whom? It gives information about subshell. It gives information about subshell. And what else? Yes, it also gives information about the energy of orbitals. It also gives information about energy of orbitals. It also gives information about the shape of orbitals. It also gives information about shapes of orbitals. So these are very crucial, very important information given by the azimuthal quantum number. Subshell, it gives information about the subshell. It gives information about the shapes of orbitals. It gives information about the energy of orbitals. Is that right? And next orbital, next quantum number. Let's have the third quantum number given by Schrödinger to explain or to give information about the electrons in an atom or electron in an atom. The third is the C, that is magnetic quantum number. It's represented by a symbol ms, or simply you can say M. Magnetic quantum number. Symbol we have seen, its symbol is, you can write by ms or M. It also have a relationship between. There's a relationship between the magnetic quantum number and azimuthal quantum number. When you have principal quantum number, you can calculate azimuthal quantum number. And when you have azimuthal quantum number, you can calculate magnetic quantum number. Or simply you can say, if you have principal quantum number, you can calculate magnetic quantum number. Anything you can say. So relationship between L, or simply I can write ML and MS, magnetic quantum number. Is that right? ML and MS. So this is not MS. Sorry. There is a problem over here. This is magnetic quantum number is represented by ML. It is not called MS. So the relationship between azimuthal and magnetic, azimuthal is L, right? And magnetic is ML, or simply M. This is azimuthal and this is magnetic. So relationship between the two is, that is minus L to 0, ML will be minus L to 0, minus L to 0 to plus L. Kindly check if I have written anywhere magnetic quantum number MS, correct it by writing ML. That is not MS. MS is spin quantum number, as I have told you. Kindly correct it. Otherwise, it will take a lot of time for me to record another video, only for this small error. Kindly, if anywhere I have written azimuthal quantum number as ML, kindly correct it by L, and magnetic quantum number is ML, not MS. So this is the relation. For example, if L is 3, then what are the possible values? If L is 3, what are the possible values of ML, magnetic quantum number? Minus L, minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. Look at it. Minus L, 2, 0, 2 plus L. L, 3. So minus 3 to plus 3. Minus L to 0, 2 plus L. Minus 3, 0, plus 3. This is your magnetic quantum number, and what information it gives. Very significant information. It gives a very important information this provides. So let's have the significance of magnetic quantum number. It gives information about the orientation of orbital in space. Means whether the orbital is in x-axis, y-axis, or z-axis. Space, it has three orientation: x, horizontal, y-axis, z-axis. Or in chemistry, this axis also taken as z-axis, this is y-axis. Or you can say this axis is taken as z-axis, or this is as y-axis. Mathematically and in chemistry, there's a specific differences there. So magnetic quantum number, it gives information about significance of this quantum number. First, it gives GIVS, orientation of orientation of orbitals in space of an atom. Orientation of orbitals. And another important significance, it also gives the number of orbitals. Number of orbitals. Look what these quantum numbers are doing. They are giving information about the electron in an atom. Principal quantum number is saying or telling about the shell, energy of the shell, and size of the shell. Or you can say size of the orbital, energy of the orbital, and the shell or orbit. The azimuthal quantum number is in giving information about the subshell, the shape of the subshell, and it also gives the energy of the subshell or orbital. The magnetic quantum number, it is giving information about the orientation of the orbitals in space and the number of orbitals also. And the last one, that is the spin quantum number, which was discovered later on in the discovery, was it gave information about the spin of an electron, whether the electron is going clockwise, up arrow, or anti-clockwise, down arrow. The last is spin quantum number. It is represented by ms or simply s. Spin quantum number symbol. This is a symbol of spin quantum number. It can be, it describes or it tells about the spin of an electron in the atom or orbital. And there is only two possibilities are there. Either the electron can spin clockwise or it can spin anti-clockwise. Whether clockwise or anti-clockwise. So this is all about your quantum numbers. These are the basic concept about the quantum number. Let's have a question on this one. Let's have a question. Please note it down. Let's have a question on this one. Suppose that if we have n is equal to 3, what are the possible values of azimuthal quantum number, that is L, magnetic quantum number, that is ML, and spin quantum number, that is S. Let's have there. So if n is equal to 3, then L will be 0 to n minus 1. So possible values of this is 0 to 3 minus 1, what we have done earlier also, this question, 0 to 2 or 0, 1, 2. What is ML? Magnetic quantum number, this is minus L, 2, 0, 2 plus L. What is the highest value of L? 2. So what are take the highest value of L, because it will include all others. Minus 2, minus 1, 0, plus 1, and plus 2. Possible values of ML, there are 5 possible values of ML. Minus 2, minus 1, 0, plus 1, and plus 2. And what are the values of spin quantum number? It can be any one. Clockwise, plus half, or minus half. Not related with this. It has either clockwise spin or anti-clockwise spin. So these are the possibilities. If n is given or L is given or ML, we can calculate any other depending if one of the things are present, if one of the numbers are present. Let's have a question on this one. The possible values of the possible values of A, n is equal to 2, L is equal to minus 1, ML is equal to 0, and S is equal to plus of. B, if n is equal to 2, L is equal to minus 2, ML is equal to minus 1, S is equal to plus of. If C, let's have a, if n is equal to 2, L is equal to 2, ML is equal to minus 2, and S is equal to minus half. And if n is equal to 2, L is equal to 0, ML is equal to 0, and S is equal to minus half. Let's have this particular question. The possible values which are possible. I'm not saying only one option is correct. Maybe there are more than one option correct, or there may be one option correct. Let's check it. If n is equal to 2, I'm writing over here. If n is equal to 2, then what are the possible values of L? 0 to n minus 1, that is 0 to 2 minus 1, that is 0, 1. 2 minus 1 is 1. There are only two possible values of L, that is 0 and 1. Then ML, minus 1, 0, and plus 1. Right? And then S, it can be plus half or it can be minus half. So check it out. If n is equal to 2, whether it is possible to have L is equal to minus 1, L minus 1, not possible. So this option is wrong. L is not possible minus 2. ML minus 1 to 0 to plus L. ML is 0. 0 is possible. S, it can be plus half or minus half. It can be. So this option is wrong now because one of the terms is wrong. L is equal to minus 1, which is not possible. Now let's look at the second one. L is equal to minus 2. Is it possible? No. ML minus 1. ML minus 1 is possible. S plus half is possible. So this also went wrong because of this one. Because of this one. Is it right? Third option. L is 2 possible. L2 not possible. Only two values are there. That is 0 and 1. L minus 2 is possible. L minus 2 not possible. It has minus 1, 0 and plus 1 maximum values. S, it can be there. So this is also wrong because of this value and because of this value. These two values are wrong. Now look at the last one. If n is equal to 2, is it possible L is equal to 0? Yes, L is equal to 0 is possible. Is it possible ML is equal to 0? Yes, ML is equal to 0 is also possible. And is it possible S equal to minus half? Yes, it can be possible. Because S can be any value, either plus half or minus half. So this option is correct. This option is correct. So these are the questions which can be asked on principal quantum number, azimuthal quantum number, spin quantum number, and magnetic quantum number. And there can be other number of questions which can arise or which can be asked from this particular number. This is very, very important topic of atomic structure. So next questions of NEET level as well as IIT-JEE level will have the other video. Please go through it and see you again. Thank you.